to record. Okay, so I'm going to talk about another problem in Webassign. It goes like this. Let's say that we're going to suppose that 4-year-olds in a certain country average 3 hours a day unsupervised, and that most of the unsupervised children live in rural areas considered safe. So suppose that the standard deviation is 1.8 hours, and the amount of time spent alone is normally distributed. We randomly survey one 4-year-old living in a rural area, and we're interested in the amount of time the child spends alone per day. So first of all, let's define what we mean by a random variable. We look at the different choices right here, and it looks like what we're talking about is time. So we definitely want to have a variable x be defined in terms of time. So our choices are the time in hours that a 4-year-old spends unsupervised per week, or is it per day, or the time in hours the child spends unsupervised per day. Let's see. And then there's the number of 4-year-old children that live in the rural areas, and the number of people that live. So it's got to be, it says 4-year-olds in a certain country spend an average of 3 hours a day unsupervised. So that's the description right here, and it looks like we're talking about 4-year-olds, and we're talking about how many hours each day they're unsupervised. Right? And they say this is from a normal distribution. So here's the way the normal distribution expression works. If we want to write a normal distribution in the proper notation right here, we state this: x is a normal distribution, and in parentheses we put the mean of that distribution and the standard deviation. Right? So in our example, we're going to say x is a normal distribution, n, and we said that the mean was 3 hours a day with on average, with 1.8 hours as a standard deviation. So this illustrates right here one thing to us. If we go to our curve, that means that the mean is 3 hours. Let me get my pen going here. The mean of our standard deviation is 3 hours. Right? And our standard deviation is 1.8 hours. So that means if we went 1.8 hours to the right, we'd be at 4.8 hours. If we went 1.8 hours to the left, we'd be at, 1.2 hours unsupervised. Right? And so on down the list. So these correspond right here, by the way, to a score of z equals 0. This would correspond to a score of z equals positive 1. And this would correspond to a score of z equals negative 1. Right? And you could do the calculation, right? If you put in 4.8, we'd say, well, z is equal to 4.8 minus 3 divided by 1.8. And a little bit of algebra shows you get 1.8 divided by 1.8, which is 1, right? So that's 1 standard deviation to the right. So, okay, now let's go back to the problem. So suppose we want to find the probability that the child spends less than 1 hour per day unsupervised. How are we going to write that probability statement? So what we're looking at right here in writing a probability statement goes like this. I'm always interested in a probability. So we write P for probability that X is, let's say, less than 1 hour. So we're going to say less than 1 hour unsupervised. And what we're doing when we say that is that, well, here's my 1.2 hour mark. So 1 hour is slightly less than that. What we're really asking for is what is the area to the left of that 1 hour mark. because that area will be exactly equal to the probability right here. So we're saying, okay, x equals 1 is the time right here on the curve. The area under the curve to the left of this number is that probability that x is less than 1 hour, or less than or equal to 1 hour per day, unsupervised. Alright, so if I'm doing this in my problem, I'm going to write my probability statement this way. I'm going to write x, let's go to relations right here, is less than or equal to 1. And we want to figure out what that probability is. So this is where I'm going to use Excel. In Excel, we said that our mean was equal to 3 and that our standard deviation was equal to 1.8. Not 1/8, 1.8. Good Lord, what's the matter with you, Professor Peoples? Okay. So, if I want to find out what that probability is, here's the way I'm going to do it in Excel. My command goes like this. The command we use in Excel, and I'm just going to type in a model of it. This is not how you type it in, because it's just always starts with equals. But it's going to be norm.dist. And what you're going to do is you're going to put in the x value you're trying to figure out is less than. You're going to put in your mean and your standard deviation. And then you're going to enter in true to represent the fact that your probability is going to be cumulative. That is, for all of the times that are to the left of that number. Alright, so when I type this into my formula, this is the way I'm going to type it in to get my probability. I'm going to go equals norm.dist, and you'll see that the formula pops up now. And it actually gives you some guidance of what to put in. We said we wanted less than 1 hour, so that becomes x for us in this formula. Our mean, we said, was 3 hours, so we put that in, comma. And then our standard deviation, which we said was 1.8 hours, comma, and we choose true because we want the cumulative distribution function, the CDF. And this is going to give us our probability that x is to the left of that 1 hour mark. And in this case, that's 0.13326. It wants you to give it to 4 decimal places, so we're going to put 0.1333. And we're going to have to pick a graph to demonstrate what that means. And we see that this graph right over here is the one that looks the most like what I was trying to draw on my board right here, right? So that's the one that we're going to use. All right. So now let's take a look. What is the percentage of children that spend over 10 hours a day unsupervised? Well, this is a harder one. Let me show you what that means graphically first, I guess. So the second problem is asking, well, what percentage spend their time more than 10 hours a day? Well, okay, so 4.8 doesn't quite do it. If I keep adding it on, let's say 10 hours is way up here. And we're essentially trying to find the area under the curve up here on this piece. Right? What we really want to do right here, if we want to get the area under the curve that's to the right of a certain point, let me just draw a curve right here to exaggerate the situation. Let's say that I want this area up here. The thing that you have to realize is that this area up here, I'll call it the high area, is going to be found by doing this. In Excel and on our table, we always get the area that is to the left. Or area low, let's call it the low area right here, right? That's what we calculated when we did this, right? When we got the automatically, we just got it to the left because that's what Excel does. But if we want it to the right, what we're going to have to do is we're going to have to take 1 minus the area to the left to get that probability. Alright, so here's what we're going to have to do. What we're really looking for right here is the probability that x is greater than or equal to 10 hours a day. And to get that, what we're going to have to do is take 1 and subtract from it the probability that x is less than or equal to 10. Alright, so let me do that in Excel for you. Alright, we want the probability that x is greater than 10. And so to get that, what we're going to do is we're going to use 1 minus the normal distribution. X is 10 in this case. We're going to enter in our mean, our standard deviation, and we're going to choose true because, again, we want the cumulative distribution. We always want true, by the way, for this statement. All right, here it is. If I hit enter, ooh, boy, that gives me some really small number right there. If you don't recognize that kind of number, that number right there is scientific notation. I don't know if you remember scientific notation, but it's kind of like saying 5.035 times 10 to the negative 5, right? So we're saying that's like 5.035 times 10 to the negative 5, and that's like saying 0.1234535. So we have to go 5 decimal places to the left to get that number. Well, what does that mean in our problem? Well, what percentage spend over 10 hours? If we're rounding to 4 decimal places, it's going to be 0.0000. That can happen, right? It's almost impossible to find children that are more than 10 hours, 4-year-olds that are more than 10 hours per day. 80% of the children spend at least how long per day unsupervised? Well, this time we're given the percentage. This time we're given the percentage. So again, let me just show you one last illustration of what that means. To me, what this is going to mean is that if I were to look at my curve, this time I'm given the probability, I'm told that 80%, the area under here, we're given that area is 80%. So that's our probability. So what we have to do is we have to work it backwards and find the x value that goes with it. Right? So this is where I'll show you the trick in Excel. There's another command that we can use. And the command in this case goes like this. We know that the probability that x being less than some value, some other given value of x, we don't know what it is equal to 0.8 already. So we're going to use a command that looks like this. It look like equals times equals norm.inv. And we're going to put in our probability value. We're going to put in our mean standard deviation. And that's going to give us a probability. So let me show you how this works. In this example, I'm going to type it in. Equals norm.inv. So we put in our probability of 0.8 this time. We already know that part. Our mean is 3 and our standard deviation is 1.8. So it's going to give us a number that would represent that number of hours. And in this case, that's 4.5149. Well, to 2 decimal places, that's 4.51. So that's how we're getting our answers right here for these normal distributions. All right, and I'm looking at the time right here, and I'm right up against it. So let me stop this